architecture. Yes. Okay, good morning all of you. So today we'll gonna see architecture of 8086. Okay, now first thing that you need to understand is 8086 is 16-bit processor. Now why it is called 16-bit processor? Because it can process 16-bit data at a time. What that mean? My data bus can carry 16 bit of data at a time. That's why it is 16-bit processor. Yes, yeah, this is one of the reason. Another reason is all the registers and the capacity of my arithmetic and logical unit inside my microprocessor is 16-bit. So in 8086, if I want to do any operation, that operation is of maximum of 16-bit operation. And because of this, my 8086 is called 16-bit processor. Am I making myself clear? Yes?
Yes, sir.
Okay, so that's why your 8086 is 16-bit processor. Keep this in mind. Fine? Yes.
Yes, sir.
Okay. Now, next thing is, if you see the architecture of 8086, the architecture of 8086 is divided into two parts. The first part is called BIU, another part is called EU. BIU is bus interface unit, EU is execution unit. Okay, bus interface unit and execution unit. Now, the first question that should come to your mind is why the architecture is divided into two parts? Why it is not a single stuff? Why it is divided into two parts? Can someone tell me why the architecture is divided into two parts? Hello?
What?
Anyone? Okay, the reason is pipelining. And because of that, your processor is divided into two parts. Now, why we need pipeline? So first thing that you need to keep in mind is any processor, if you study 8086 or Intel i9 processor, any processor at the end of the day doing three things only. Keep that in mind. Fetch, decode, execute. Fetch, decode, and execute. It fetch the instruction, decode the instruction, and it will execute it. Okay, this is the basic work of any microprocessor. If you understand this thing, just follow the pattern and you can understand any damn architecture available to you. Clear?
Yes, sir.
Okay, now our question is why my 8086 is divided into BIU and EU, two units. So let's discuss. As I said, because of the pipelining concept, we have divided into two parts. Now, why we need pipeline? The reason is we want to increase the speed of our processor. Yes?
Yes, sir.
How you can increase the speed of your processor? Can you tell me? તમારે તમારા પ્રોસેસરની સ્પીડ વધારવી હોય, which are the different ways by which you can increase the speed? Hello? How you do?
Hello.
Huh? Yes? How you can increase the speed? Anyone? Are you not able to even read? Are you there? Am I audible? SSD. SSD is not actually increasing. It is increasing the speed of data fetching. Okay, so fetch operation get faster because of SSD. So that is fine. But technically,
by increasing clock speed.
very nice. By increasing the clock speed. Very good. The whoever is answering this is nice. As I have mentioned over here, the first thing that you can do with your processor to increase the speed is increase the hardware capacity. Now, by increasing the hardware capacity means what? By data bus. As we have already discussed, our 8086 is 16-bit data bus. It is having 16-bit data bus. What that means? 8086 can fetch 16-bit data at a time. If I increase my data bus size to 32-bit, now I can fetch 32-bit data at a time. So my speed will get automatically increased. The same operation initially required 2 clock cycle. Now it requires only 1 clock cycle. And we know that our all current processors are of 64-bit. What that means? We are having 64-bit data bus available. What that means? At a time, I can fetch 64-bit of data from my processor. Yes, memory. Hello.
Yes, sir.
So the same task which 8086 do in 4 clock cycle, currently we are doing in 1 clock cycle. So speed is increased, right? Yes.
Yes, sir.
Yes, sir.
Second way is, as someone rightly mentioned, you can increase the clock pulse. What do you mean by clock pulse? If in 1 second, if I can execute 2 instructions, if I increase my clock pulse speed in 0.5 second, now I can execute that 2 clock cycle. So the same thing that you are doing with 1 second, now you can do it in half second. Again, if you increase the clock pulse, it can get reduced and you can do it in still lesser time. So that is one more option that you can do. Increase the clock frequency so that the time required to perform one clock cycle or one instruction get reduced. But now if you can concentrate carefully, currently we are using 64 bit of data bus. From 2012 it is 64 bit only, so there is no much change in this. Our clock frequency currently we are using 3.2 to 3.6 gigahertz, and still our laptops are working on the same frequency. So there are hardware limitations, and because of that now you can't go further with your data bus size increase or your clock frequency increase. That is not possible. Understand?
Yes, sir.
Because of the hardware limitations, now here we are having the limitations. Since last a decade we are having the same data bus and same frequency. Then what you can do to increase the size of your speed of your data processor? So the next option available is this, pipelining. Now what is pipelining? Let's discuss that in detail. So if we talk about the processor 8085, which is the previous generation of 8086, it is not having pipelining. While in 8086 we are having pipeline. It is called one stage pipeline. Now I will explain how it is one stage pipeline. So let's discuss. I want to suppose execute 5 instruction, okay, and I don't have any pipeline available. So what happens in the background? I will fetch the instruction, execute the instruction, fetch the instruction, execute the instruction, and it done serially. So once I fetch first instruction, execute it. Once it gets over, then I fetch the next instruction. So here it will take almost 10 cycles, right, to complete my 5 instruction. Yes or no?
Yes, sir.
Okay. Sorry, give me a minute. I will come to you. Give me a 5. So, are you able to see my screen?
Yes, sir.
Yes, sir. So in normal 8085 processor, what happens? You fetch the instruction, you execute the instruction. You fetch the instruction, you execute the instruction. There is no pipeline available. So the problem is, if you want to execute 5 instructions, you require 10 cycles. Yes? Is it fine? Is it fine? Hello? Are you there? Okay. Now in 8086, we are having 2-stage pipeline. What that means? When you execute any instruction, your processor is used, but your buses are free. So actually your buses are get wasted during your execution time. So what they have thought of is, while executing my instruction, if I use my buses to fetch my next instruction, it would increase my speed. So here what happens? You have divided your instruction into 2 parts: fetch, execute. So while my processor is executing one instruction, at that point of time I am fetching my next instruction. So I have fetched my first instruction, it goes for execution. While it is getting executed, at the same time I am fetching my next instruction. So fetching will be done parallelly. Again, when I am executing my second instruction, I am fetching my third instruction. Get it? So now the same 5 instruction will get executed in 1, 2, 3, 4, 5, and 6 clock cycles. So my speed get increased. Initially, the thing which was taken 10 clock cycle, now it requires only 6 clock cycle. Is it clear?
Yes, sir.
So by pipelining, you can increase the speed. This is called 2-stage pipeline. Why it is called 2-stage pipeline? Because we have divided our instruction into 2 parts, fetch and execute. So 2 things can done parallelly, and that's why it is 1-stage or 2-stage pipeline. So by 2-stage pipeline, you can increase the speed. Get it? Yes. Hello.
Sir.
Yes.
Yes, sir.
Okay. So now if I want to increase more speed of my processor, what I can do? I can increase these stages. If I divide my instruction into more number of stages, more number of operations can be done parallelly. Understand? Hello. I have divided my instruction execution in 2 cycles, fetch and execute. So now 2 things can done parallelly. If I divide it into 3 parts, fetch, decode, and execute, then 3 instructions can work parallelly. Get it?
Yes, sir.
Hello. So this is called Three-stage pipeline. Same way, if I divide my instruction into fetch, decode, execute, and store, I store the result separately, then it is called four-stage pipeline. So by dividing your instruction into number of stages, you can increase your number of stages, or parallel instructions can get executed more frequently. Get it? Hello?
Yes, sir.
In Pentium processor, they have introduced five-stage pipeline. So your one instruction is divided into five parts. And so how many instructions can executed at a time? In five-stage pipeline, how many instructions can executed parallelly? Hello? Can someone tell me? If I'm having a five-stage pipeline, how many instructions executed parallelly or work parallelly? Five instructions, right?
Yes, sir.
Hello? One will be executed at the same time, one will be decoded, one will be fetched, one will be stored. Get it?
Yes, sir.
Okay, but if you read it carefully, they are working on 10 instructions simultaneously. How? They have make two pipe. So in one pipe, instructions are stored at the same time. Another pipe is also available which stores the instruction executed. In today's modern world, we are calling it as a core, number of cores. So one core can execute, and at the same time another core can also work, and that's how you can increase the speed of your processor. This is called superscalar pipeline. Get it? Hello?
No,
Hello?
sir.
Understand?
No, sir.
Okay. I can make two pipes, as you can see over here. One instruction is stored here, second instruction is stored in another core. So at a time this will get fetched, and second time this will get fetched. So at a time I am having two cores, so at the same time two pipeline will work in process. So both things will work in work together. So if you want to increase the speed, one is you can divide your instruction into number of stages. Second thing is you can increase number of pipes, number of cores are increased. So here also my processing is done, here also my processing is done. I just need to execute this one, execute this one, execute this one, this one. So at a time I can do tasks parallelly. Get it or not?
Yes, sir.
See, I want to check your journal. This is the simple example, right? One way is, one will be only do the tick mark. This is one task. I will sign it. This is my second task. Now, if I want to do it faster, I will allocate Tirthesh to do the tick mark, and I will only sign. So it will get faster to me. Now, instead of Tirthesh, I will allocate one more student also. So it is also doing the tick mark. So he is also doing the same thing parallelly. So now I am having two students who can do tick mark, and I just need to sign. So work get faster. Yes.
Yes, sir.
So same concept is applied over here. You can divide your instruction into number of stages. This is one way to increase the speed. Second way is increase number of pipes. That is number of cores. So by this way, you can increase the speed of your processor. In 2000, Pentium has launched a new architecture called net burst architecture, which can have four pipes, and each instruction is divided into 20 stages. So at a time, you can work on 80 instructions. Understand? Hello?
Yes, sir.
Because I am having four different pipes available, and each pipe can execute 20 instructions parallelly. So 80 instructions are working in the background parallelly. That is the advantage of net burst architecture. So by this way, nowadays we are having 8 core, 4 core, and because of that, there are multiple pipes in each core, and instruction is divided in so many parts. And because of that, our processors are very fast. So that's why pipelining is very important. Understand?
Yes, sir.
Yes, sir.
Sir.
Huh? Okay, done? Now, is there all advantages? No, there are some disadvantages also. What are the disadvantages? One is called data dependency. Like suppose I'm having an instruction answer is equal to A plus B, and my next instruction is X is equal to answer into 2. So in this case, these instructions answer value is like my second instruction is depending on that answer value. So if I don't get my answer, I can't execute this instruction. Understand? This is called dependency. Yes.
Yes, sir.
So though you have fetched 80 instructions in advance, you can't execute this instruction fast. So this is the problem. So to solve this problem, what they have proposed is, at the end of the day, your C language program or C++ language program is converted into binary at the end, right? So you need to write down machine language program. So it is converted into assembly language program or machine level program. So when you convert your C program or C++ program into machine level program, you need to convert it in such a way that you can reduce this dependency. So that is how you can overcome this drawback. Your machine level program or assembly level program should be such that the dependency will be reduced. Okay? Hello.
Yes, sir.
So this is
Yes,
one
sir.
problem and this is the solution. Second problem is called branching. You know that you are having if-else condition. Now, while pipelining, we assume that everything will go in sequence, right? 1, 2, 3, 4, 5, 6, 7. So we'll fetch 80 instructions in sequence. But what if my condition gets fails and I need to jump to another location? These 80 instructions that I have fetched in advance go in vain. You just need to remove it, flush it. So your all hard work is go into vain. That is the problem. Fine. So pipeline is always fail when you are having a branching. That is the problem with branching. Done? Hello? So much for it. So when you are having if-else statement, you need to jump somewhere and you need to execute another instruction which is already not fetched. So in these kind of cases, your pipeline will get failed. Then what is the solution to that? For solution to that, they have developed branch prediction algorithm. What is branch prediction algorithm? In branch prediction algorithm, they predict that the current if condition will get true or false based on the history. So they manage the history. And this kind of algorithms gives more than 90% accuracy, even 98% accuracy. And because of that, you always predict that this particular instruction will jump on branch or not. Understand? Hello. So in nowadays current laptops, we don't have even branching problem also in pipelining. So what we have covered in today's session, 8086 is 16-bit processor, which means that it can operate on 16-bit data at a time. Second thing is we are having two units in 8086, BIU and EU. Now why they have divided this thing into two parts? Because of pipelining. Now why we need pipelining? To increase the speed of our processor. How you can increase the speed of a processor using pipelining? By two ways. One way is simply divide your instruction into number of stages or increase number of pipes. In today's world, it is called core also. There are two disadvantages of pipeline. One is data dependency and one is branching, but both can be solved. One can be solved by machine instruction. Branching can be solved using branch prediction algorithm. Done? Hello.
Yes, sir.
So this is what you need to understand as far as pipelining is concerned, and that's it for today's session. I will share the link of this video soon in a group so you can watch it. Fine? For revision purpose. Yesterday also I shared the same video so you can refer that video also. Okay?
सर
Yes?
सर ये ब्रांच प्रिडिक्शन एल्गोरिथम टारगेट क्या होता है?
वो क्या होता है मतलब ब्रांच प्रेडिक्शन एल्गोरिथम का?
सर ये ब्रांच टारगेट प्लस हिस्ट्री मेन फ्रेम लिखा है सर, ये ब्रांच टारगेट क्या होता है?
Like what next instruction is a branch instruction, it will going to jump or not, that will need to decide. I need to decide my branch target. So it is a algorithm which itself a research topic. It is a big subject that is not in our syllabus. So right now what you need to understand is a problem comes by pipelining is what if branch is there, it will create a problem. Yes, because we need to jump somewhere else and all the instructions that we have prefetched we need to remove it. Yes.
Yes sir.
So in this case, my pipelining will get failed. So if we don't want to do that, what we do is when fetching the instruction and while decoding, we apply this algorithm on our instructions, branch prediction algorithm, and it will predict based on the history that this particular instruction will jump or not. And based on that, our next instruction will be fetched. So instead of fetching 80 instruction in sequence, we'll fetch instruction in different places so that our loss will be less. That is what your branch prediction algorithm do. And branch prediction algorithm gives 98% accuracy. Now, we are not going into depth of this algorithm. We just need to understand that this algorithm is present. This is the solution. Okay?
Yes sir.
Done?
Done.
Sir, can you share any book for the subject?
You just need to refer my videos. That's it. It is more than sufficient. And you can make your own notes. Fine.
બટ સર બુક હશે તો સારું પડશે વાંચવા માટે.
Will provide you soon because it will given to you from the college also. 8086 by Douglas Hall. That is the textbook that you can follow.